Okay, for our first equation, we're going to use our pattern blocks to look at how fractions work. So I want everyone to get out their pattern blocks. And first we're going to pick out a red trapezoid. Okay, so I want you to go ahead and trace that for me and make sure we trace it exactly so that we can really understand how fractions work and how they fit within other things. So let's trace that trapezoid. You can go and take it off and color that in red for me. Okay, for this equation, our trapezoid is going to represent our unit of wholeness. So can anyone tell me the value of our trapezoid? 1, that's correct. So our trapezoid is our unit of wholeness. Okay, so if a trapezoid is equal to 1, what is the value of the green triangle? Okay, let's start this by just taking out our green triangle. Let's go ahead and trace it just so we can get a look at it. And let's also trace our trapezoid because we know that's our unit of wholeness and that's what we're trying to decide. What's a way we can look at this to decide the value of the green triangle with a trapezoid being our unit of wholeness? Okay, yeah, we can decide how many of our green triangles fit within this one unit of wholeness. So go ahead and color those in. So let's just get out some triangles. And let's take those and see how many fit within this one trapezoid that's our unit of wholeness. Now remember, you might have to turn them around in different ways and really just play with these to see how they fit. So now we see 2 fit within. And then we see 1 more, and see how that covers the whole trapezoid perfectly. We don't have any red showing and we're not overlapping anywhere. So you can go ahead and color those in. Let's just go ahead and draw that on there. Okay, so what does this tell us about the value of the green triangle? Okay. Okay, so let's write that in fraction terms. So we know that we have our unit of wholeness, which is going to be on top because we know that it's 1. That's what we're trying to represent with our triangles. How many of these triangles fit within our 1 unit of wholeness? 1, 2, 3. That's correct. So 3 is going to be our denominator. So that tells us that our 1 triangle represents 1/3 of our whole trapezoid. Okay, can anyone explain to me why it's 1/3 of the trapezoid? Why our 1 triangle is 1/3? That's correct, because it represents 1 of 3 that fit within the 1 trapezoid. Okay, with this information, we're going to try and solve an equation using, our trapezoid is going to remain our unit of wholeness. So let's go ahead and trace that trapezoid again. And color it in for me. And we're going to subtract that 1 trapezoid by our 1 triangle. Go ahead and color that in. Okay, does anyone have any ideas of how we could solve this equation? Okay, so we're going to start with our unit of wholeness. That's what we're subtracting from. Okay, so you think we should put our triangle on top. Okay, so what does this red area represent? Correct, it represents the solution. We know this is what our answer is going to be. This empty space is the answer to one trapezoid subtracted by one green triangle. So let's get out some patterned blocks and just really look at them, and let's compare it to our shape or our remaining what's remaining in our trapezoid. Okay, so let's try this. Not quite. We have some overlapping and we're missing some there. That's way too big. No. That's perfect. See how that covers up all of that remaining red and we don't have any overlapping anywhere. So that tells us that for this equation, our solution would be one rhombus. Okay, let's go ahead and color that in blue. Okay, so this gives us our solution in terms of pattern blocks. But if we're wanting to get it in terms of a fraction like we got for our triangle, we're going to have to take it a step further. So we know the answer is 1 rhombi. So what could we do? Well, let's first look at what we already know. What do we already know about the equation? Okay, that's right. We know that our trapezoid represents 1. Okay, what else do we know? Looking at what we've written and what we've solved, what else do we know? Correct. We know that our green triangle represents 1/3. So what could we do with that information? Okay, so let's see about how many of our 1/3 triangles are going to fit within our rhombus. So there's 1, and there's 2. So we'll go ahead and trace these because they're equal. We'll go ahead and color those in just so we know what we're looking at. Okay, how can we use this information to decide what our solution to this problem is going to be? Okay, so we're going to look at our green triangle. So that tells us we know that each of these is worth 1/3. So we'll do 1/3 plus 1/3 equals, and then how can we solve that? Okay, let's look at our numerators and we'll add those. So 1 plus 1 and we get 2. And what do we do with the denominator? Because we know that this represents the total number of triangles that fit within our whole trapezoid. That's correct, it stays the same because it's always 1 of 3. So our solution to 1 trapezoid subtracted by 1 triangle equals 2/3. Okay, next we're going to solve an equation using our fraction circles. Okay, so everyone get out your fraction circles. We're going to use these. And our equation for this is going to be 3/4 subtracted by 2/8. Okay. Which section do we need to represent our 3/4? Okay, yeah, correct. We need our blue 1/4. Okay, to reach this fraction, how many of these 1/4 do we need? 3, that's correct. Can you tell me why? Right, because we have 3/4, which is 3 1/4. Okay, so let's find 4 or 3 of those. And go ahead and trace those for me. And I'm going to go ahead and write in their values just so I remember. 1/4 1/4 and 1/4. Let's get out that blue crayon. Okay, so we're subtracting. Oh. I don't know what to do. Okay, this is actually an addition problem, sorry. We're going to go be adding the 2/8. So let's get out our 2/8. Okay, what could we be doing? Okay, which sections do we need to represent our 2/8? The red, correct. Okay, so how many of those do we need? 2, right, just like we talked about, because our numerator is 2. We need 2/8. So let's trace those as well. Now I'm going to go ahead and write that in again. 1/8. 1/8. Got that red crayon. Okay, so that's addition. So here we have our equation, and then this shows us in terms of our fraction circles the equation. So I'm going to go ahead and take all of those. I'm going to take my 3/4, and then I'm going to grab my 2/8, and I'm going to put those together and see what we have. So let's slide those together. Can anyone tell me what they notice when they look at their fraction circles when they're put together? Okay. Okay, you think it's worth 1? You say that it's a circle? Okay, well let's trace it first, and then we'll talk about it. Okay, go ahead and write those values in there. Okay, so I'm going to have everybody, after you get done coloring these in and drawing it out, I'm going to have you grab that yellow 1. And we're going to put it over this and see what we notice. Okay, I got mine. So let's see. It covers it perfectly. So what does that tell us about this equation and its value? Yes, correct, that it is equal to 1 whole. Okay, great job. Now we're going to look at fractions using our Cuisenaire rods. So everyone get out your Cuisenaire rods. Okay, for this equation we're going to use 2/4 subtracted by 3/8. Okay, so using what we know about Cuisenaire rods, how could we represent this? Okay, so you think we need a 2 and a 4. Okay, let's get that out. We know our red is worth 2 and our purple is worth 4. We're going to go ahead and trace these so we can get a good visual as we move our rods. There's that. And then we need, how can we represent this? Knowing that we used the 2 and the 4 to represent this, what do we need to represent our 3/8? A 3 and an 8. Okay, so can anyone tell me what color the 3 is? Okay, lime green. And then I know that the 8 is brown. So we're going to place that next to it and go ahead and trace that again for me. We're going to put the subtraction there because we know that we're subtracting this equation from, or this fraction from this fraction. So we'll take a little time for everyone to dig out those colors so that we can go ahead and color those in to get a good representation. So there's our red and our purple. For our green and our brown. Okay, looking at this, can anyone tell me what we need to do to take this equation further so that we can solve it? Okay, so we need to get our denominators looking the same. Okay, to do that we need to figure out which one is larger, which denominator is larger. Correct, the 8. So we need to find a way to get this purple to fit within the 8. So I'm going to grab just a few purples so we can take a look at this. So there's our brown 8. So let's see. Not quite, it doesn't fit quite yet. And then we put 2 within it, and can anyone tell me what you see? Correct, they're equal. So we know that we need 2 4s to fit within this 1 8. So we'll go ahead and carry this over. Now you can represent this part a few different ways. You can either keep this 8 for this side, or if you'd rather, you can represent that with the 2 4s so that they look the same. I'm going to go ahead and keep that brown 8 there. So since that brown 8 stayed the same, what do I need to do to the top? Right, it stays the same. Okay, so I'll move that lime green 3. So, for this next part, how many purples did we need to represent the 8? 2, right, because 4 plus 4 is 8. So what do we need to do to the top since we doubled the bottom? Okay, we need to double it as well. So here's my 2 4ths and my 2 4ths. So I'm going to go ahead and push those together. We're going to take a little minute to just trace those. Okay, and we're going to trace the other side. This will be nice later when you're wanting to visualize it and look at it. You can really just see what the values of each are. So there's our 3 8s. Okay, so let's get out our colors again and go ahead and color that in. Then we have our 2 4s, so we need our purple. And then can anyone remind me of what the color we need for our 2s? Right, red. So we're going to color both those 2s in red. Okay, for this next step we want to write the same equation, but we want to just use one rod to represent the numerator and the denominator of each fraction. So our 3 8s can stay the same, correct? Because we already have our 1 and 1. So go ahead and get out your brown and your green. I'm going to go ahead and trace that just so we can get that part done. Okay, so what do we need to do? We know that our 4 and our 4 is equal to our 8, so what do we need on this side for this denominator? Brown, right, so we have it looking the same. So now we have our brown. And for the numerator, we know that we have 2 2s. So what could we do to get those 2 2's to just be one rod? Add them, correct. So we know that 2 plus 2 equals 4, right. And by this equation, we know that our 4 is our purple rod. So I'm going to get out the purple rod and place that above our 8. Let's go ahead and get out our crayons again. So can anyone remind me of what color I need for that? Purple. Okay, that's right. That's what I was thinking. Okay, then we need our brown for both our denominators because we got those the same. So that we can just look at those numerators. Lime green to finish it off. What do I need between these two? What type of problem are we doing? Subtraction, right? Okay. So we're going to take a look at our numerators because we know our denominator is going to stay the same. So let's go ahead and get out that brown rod rather. And then we're going to look at our top. So for me, I'm going to go ahead and take these two numerators and separate them so I can just kind of get a look at them. So we know we're subtracting our 3 from our 4. Can anyone tell me what 4 minus 3 is? 1, that's correct. So go ahead and get out your 1 block. And we're going to place that above our denominator for the solution. This is our last one to trace. Let's go ahead and color in that 8 rod. So, based on what we know about the value of these rods, what is our answer to 2/4 minus 3/8? 1/8, correct. Great job.